So what do you think, Valerie? What do you think will be the answer? What concept? Or Joanna, what concept is that?
Diffractive.
It's diffraction. We can't talk of refraction. It's bending of light when it moves from one medium to another. This is simply still in air, it's not changing medium. So when they are diffracted, no? Valerie. Now a wave, a water wave in a shallow tank passes through a gap like this. So what happens to the speed and what happens to the wavelength of the wave when it passes through that gap? What happens to the speed and what happens to the wavelength? Which person? What happens to the speed? And
The speed decreases. I think.
Speed decrease. Why does the speed decrease? No. Okay, what causes your speed to let's think of physics, eh? From what you have learned so far. What causes speed to decrease? Remember when I said, for example, if I'm moving from air to glass, because glass is more dense than air, different densities, then speed decreases here. Or if it was air to water, different densities, speed decreases. Or if I'm going the other way, speed. So it's due to density. Now my question is, this is water. Is this not water here after this? Is that not water? It's water. So if it's water, it means the density hasn't changed. Are we together? The density, yes, because we are still in water. It's just a gap and open. So why do you think the speed should change? The speed change is due to change in density. So in physics, your speed cannot change. That will be incorrect. I think speed can change. Because of that. Speed changes when you move from one density to another. In this case, we are not having that change in density. So speed remains the same. Are we together? Now, so if speed remains the same, let's think of the other part now. The wavelength. What happens to the wavelength? The wavelength, what do you think? You're saying speed decreases. Wait a moment, there is the person properly. So a gap in a barrier, when what happens to speed and what happens to the wave as it passes? Oh, okay, I didn't read through the question. It's talking about this gap here. So you're actually correct, because this gap here is, yes, at this gap here, that's correct. Speed decreases. Huh? Are we together? Very correct. Speed decrease. So what happens to the wavelength? Correct. Was a talking of what happens on the gap. So what happens to the wavelength? Remains constant. The wavelength is not affected by the gap of. What is the unit of wavelength? What is wavelength measured in? I gave you the formula V is equal to that, like that. This here we said is frequency is hertz or per second. This is what? Meters. Wavelength is distance, meters. SI unit. Are you together? Which list contains transverse waves only? So what are you eliminating? If the question is like that. What did we say is the only longitude now in physics? What did you say is the only longitude now? There's only one longitude now. Are you reading your notes? Only one longitude in a wave. What is it? Only one longitude now. Are you guys revising your notes? I said this over and over again that there's only one longitude now. The rest of the waves that you can think of are transverse. That's what I think. So what is the longitude? Sound waves. So it means you're only eliminating sound. If there is anything to do with sound, then it's not a correct answer. It's not a correct answer. The rest of the waves, water waves, microwaves, radio waves, infrared, they are all transverse. That's what it is. The only longitudinal wave in physics, I think you're not reading your notes, is sound waves. You know this by now. Now, the diagram shows you a wave. Which labeled is the wavelength? So which one is the wavelength? A, B, C, or D? Which one is the wavelength? Wavelength is which one? Wavelength. Huh? What's your answer?
C.
You're saying B.
C.
C, correct. Your wave here, then they're starting again. Or maybe from that to that, but it's not labeled here. So C. And notice D is this, not that. Otherwise, if it was that, it was wavelength. But D is this. That's not correct. So now, number 6. The diagram shows you waters that move slowly after passing into shallow water. You need to know that waves are faster in deeper water and slow in shallow water. Which diagram shows you what happens to the waves? So we are moving from fast to slow. So which answer? Do you know what this suggests here? Who can explain what this is suggesting? Yes, it's a wrong answer, but what is this suggesting? This is suggesting that the wave has got the same speed in deep water and in shallow water, because the wave here is not being refracted. So that's a wrong answer, clear? Because it's remaining straight like this. Are we together? It's not true, because now they've got different densities. Are we together?
Yes, sir.
So what do you think of if I have a question like this here? So look at this. This is a complete wave is still in deep water. Then the moment I reach here, I can try to put a normal here. A normal is something like 90 degrees here. Just think along. Then what I think, I'm trying to draw a normal here, which is 90 degrees to this. In fact, that's a wrong, because it has to be 90 degrees to this here. So maybe something like this. I'm saying a normal that is like 90 degrees to this. So now remember my physics here. If I'm moving from water that is fast to water that is slow, it means my angle here, my angle of refraction, it has to be a small angle, because the speed is what? The speed is slow. Is that making sense? It has to be a small angle here, because the speed is what? The speed is slow. This happens if I'm moving from slow to what? To fast. Because the angle here, the angle of refraction is a greater angle than this angle. Are we together? Is that making sense? So the answer is C here, because I'm moving into a slow. The first two here. Then this here is straight, because I'm now completely in one medium. So it can't bend. Are we together? This wave is now completely in one medium. Is on this here and on this, where I am changing from fast to what? To slow. Are we together? Are you guys there?
Yes, sir. Yes, sir.
What is the number of wavefronts per second that pass through a fixed point? What do you call it? Number of wavefronts that pass through a fixed point. What do you call it?
Isn't it this, sir?
You said D or B? What I said?
B, the frequency of the wave.
Simply frequency, number of complete oscillations per second. If I say 50 hertz, what it means is if I'm standing here, let's say I've got a point there and I'm standing here. If I'm saying 50, I'm saying 50 complete waves per second. I'm observing 50 of them per second. That's what it means, frequency. Number of complete waves per second. So complete oscillations per second is frequency. Now I skip this one, it's just nothing to do with the waves. Which line represents a wavefront? Which line represents a wavefront? A wavefront, which one? A wavefront is as good as a complete wave. Which one? Represents a wavefront. Wavefront is a complete wave. So which one? What do you think? Complete wave? Both of you are quiet. A can be a complete wave. Where? It's only B. B. There. From that to that. Crest to crest. Now the diagram shows you the side of a water wave at a particular time. The diagram is to full scale, is full size, so it means it's to scale. Which statement about the wave is correct? So analyze that.
Jesus.
So which one is correct?
It's
Oh, yes.
D.
Still analyzing. You're saying it's D.
Yes, sir.
Y is okay, it's a transverse. A B, the answer is between, sorry, it's between C and D, because we said all other waves are transverse. Y is, who can explain why C is wrong? There are people that guess
They
answer.
didn't give us the frequency, sir. And we can't measure it.
But now you are saying wavelength, how do you measure? They never give you the wavelength, but you can measure because, for example, you can use a ruler here and or a meter and measure this. So you are not explaining properly. Why is that we can't measure the frequency? Because look at this here. What's the reason why I can't measure the frequency? What's the definition of frequency? I said the number of complete waves per unit time per second. Are we given the time here? We are not. Even if I was to say one complete wave here, two complete waves, three complete waves, but I'm saying three in what time, I don't know. So I can't calculate frequency. Because frequency is number of complete waves. For example, these are three complete waves. But if, for example, if this was, for example, this, if we were told that the time to pass from this, the time that this passes this point is, for example, 3 seconds. Then we can calculate the frequency, because I'll say number of complete waves 3 divided by the time 3 seconds, then it's 1 hertz. Is that making sense? I'm not given the time, so I can't calculate the frequency. Is the physics making sense now?
Yes, sir.
Yeah, that's what we're talking about. Now, number 11. What is the name of the effect that causes the wave to reach point P? We talked about it. What is it? Spreading of wave when it passes through a dip. What do you call it? What do we call it? Diffraction. Which row shows you the amplitude? Analyze your answers. The amplitude and the wavelength.
D.
Do you agree with you? You said D.
Yes.
So you're saying all the way from this to this here is your wavelength. That's wrong. Wavelength is only from this, from crest to crest here. This is the wavelength here. So it actually means I've got two wavelengths here. From crest to crest. Clear. So my wave here is starting here, or from that to that here, from trough to trough. So what is my wavelength? It's 2. Clear? Are you there?
Yes.
Then your maximum is also not 2. That's wrong. Because here your wave is starting here. This is the equilibrium line here where the wave is 0 here. So the maximum here is this. The amplitude is this. The maximum height. Not this here. No. So that's twice the amplitude. This is from rest position. So it's 1. Answer is 8. Do not. Wow, the amplitude in the wave. Now, the diagram represents circular wavefronts coming from a point P. The wavefronts strike a barrier and are reflected so that they appear to come from point S. The diagram like that. Then which diagram shows you the refracted? Means they're hitting the surface and going back. So is A and B correct, or they're completely out? If I'm talking of refraction. If I'm talking of refraction, can the waves pass through this, or they bounce back? The refraction is the bouncing back. It can never go this side because we're talking of refraction. It's the bouncing back. So this is out here. We can't see anything from this side because we're talking of reflection. It's the bouncing back, it bounces back the other side. So this is out here. So which answer is correct between C and D?
It's D.
It's D. Think about it when it's being refracted. Yeah? Now goes in the other way, the other circular direction. It's bouncing back of light. Which row correctly defines the type of a wave and gives a correct example? What's the answer? Right now, you should know this.
A.
What did you say? The only longitudinal in physics is what?
So isn't it between C and D?
Didn't we say the only longitudinal wave in physics is sound? And I said all other waves are transient. Look at your example here. Radio wave, it can't be longitudinal. It can't be longitudinal. The only longitudinal is sound. I don't know why you're not getting that, what I said. So what is the answer between these two here? We need to know the definition of a transverse. What were you saying? Your answer is what? Joanna, you're saying your answer is what?
I said between C and D.
No, you can't say between. It means I'm not reading my physics. By now, this is the first thing that we did in the first lesson. By now, people are not even knowing the difference between transverse. How many times have we talked about what's the difference between a transverse and a longitudinal? We even explained, and we was there in your notes, and we even gave this here. And I said longitudinal means the individual particles in the wave are moving in the same direction. They are parallel to the direction. They are moving in the same direction with the wave. Transverse, the individual particles are moving at 90 degrees up and down. They are at 90 degrees to the direction. They are perpendicular to the direction of the wave. That's what transverse means. And look at your notes. That was the very first thing in your notes. Which means now if you are saying between, yeah, it means you haven't even understood the very first things on waves in your notes. So it means people are not studying, because this was the very first lesson. I said a longitudinal wave, the individual particles in the wave are moving in parallel in the same direction with the wave. And we said we've got the regions where particles are very close together and particles are far apart. This means areas of compression and rarefaction. That's what I said. Areas of compressions, areas of rarefactions where the particles are far apart. Is to do with the longitudinal, which is sound. That's what it is. Then if you go and check your notes, we said this is perpendicular. Individual particles are moving up and down. The wave is moving in this direction, but these individual particles are simply moving up and down at 90 degrees to the direction of the travel of the wave. That's what we say with the wave. That's what we say. Is there, please read your notes, because these are the very first things that you have mastered by now. Can't be guessing to say, hey, you have to understand. Study your notes, study the notes that I sent you right now. And I think I sent you also a video on waves. So I wonder how you'll be studying when you are not getting these things by now. Now, water waves moves quickly in deep water. So I've got deep water, shallow water. The wave now enters shallow water and its speed decreases. Yes, as we say, Which row shows what happens to the frequency and what happens to the wavelength? So we are moving from deep water to shallow water. From deep water, is that correct? Yes, from deep water to shallow water. So what happens? From deep water, shallow water. Deep water to shallow water. Does the frequency change? Remember, frequency is the number of complete oscillations. Does it change? Any change in frequency? Look at this here. If I'm moving from deep water, I don't normally want you to claim these things. I want you to mark shallow water. What we said is that the speed here, the speed here decreases. Speed decreases. Let's just say decrease. That's what they say. Frequency is actually constant. It doesn't change. Now look at your formula here. Speed is equal to frequency times. So frequency here is a constant. So this is the constant here. Clear? So if look at this here, velocity is directly proportional to the wavelength. Whatever happens to the speed here happens to the wavelength. Is that making sense? If frequency is constant from the formula here, from the physics formula. So it means the wavelength decreases. How did you get that? So it means if I was doing the opposite from shallow to deep water, I expect the speed to increase, as we said. We also expect the wavelength to increase, but the frequency to always remain what? Constant. How did you get that? What's your physics? Which two labeled points are one wavelength apart? Which ones? One wavelength apart. We talked about it, just a change of diagram, but almost similar to the other diagram. So which ones? Valerie? One wavelength apart. Which one? Oh, Joanna, Valeria is in.
Yes.
So what do you think? Which points are one wavelength apart? Joanna, I'm not sure why you guys are quiet. Which points are one wavelength apart? I thought that was actually very easy. So not even take time to think about it. Which points are one wavelength apart? You can check your answers. Which ones? And wait from the answers.
I think it's X and C.
X and?
Z.
That's obvious. That point, that point. And that's now, what is the name of this curving effect? How can the gap be changed so that the wave fronts do not reach the bottom? Good question. We want to make sure that they do not reach the bottom. What is it anyway? Is it refraction or diffraction?
Diffraction.
Refraction.
Diffraction or refraction?
Diffraction.
Reflection.
Diffraction. So do we increase the gap or do we make it correct? So my next question is, do we increase the gap or do we make it bigger or smaller?
Bigger.
We make it bigger. If we decrease it, that's what it will be close to this size here. That's why you've got maximum diffraction. So if you don't want to have diffraction, the gray, so you make it bigger, that there's less diffraction. Now this is quite obvious. Which list shows you electromagnetic waves in their increasing frequency? Increasing means from the slowest frequency from that answer to the highest frequency. So which is the correct answer? I told you you're supposed to know that order by head. So which one is the correct answer?
A.
A. Visible X-rays wireless correct. The slowest in terms of frequency will be your radio waves, but it is the greatest wavelength. Shows you the diagram. Which statement is correct? Let's look at it one by one. The amplitude of wave P is the same as amplitude of wave. The amplitude is the same. Amplitude is this. Is it the same? It's the same, huh? Can you see that? Do you agree with the first one? The amplitude of this here is the same. From according to the diagram here, it's the same. They've got different, they only have different wavelengths. Because the wavelength of this here is all the way to this here. Then the wavelength of this here is from this to this. It's actually shorter wavelength. So that's straightforward. Now, which waves are longitudinal from this instrument here? Where do we get longitudinal?
D.
D. It's the one producing sound. No, this was repeated. And who is very late?
The electricity had gone, so I couldn't log in, and the generator wasn't working. So electricity just came back. I sent you a message.
Wave travels more quickly. I think I'm answering the question. On the surface.
Can you send me the recording again?
I'll send you. Waves travel more quickly on the surface of water when the water is deep. A stone is dropped at point P into a pool of varying depth. The diagram shows you the wave fronts on the surface, the region X, and which labeled region is it likely to be deepest. So that's actually easier. Deepest, which one? Which one is further away from this point here to be deeper? A, B, D, or C? C, yeah? Which one is correct? Visible light, whatever are both waves and X-rays. So which one is correct? Longitudinal, 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 transverse, longitudinal, transverse. So the answer is D. That's what they say. Only longitudinal is up. Now, How many wave fronts are between X and Y? Look at this, between X and Y. So here, my first wave front is this here. Remember we said from crest to crest. 1 here.
3.
Not 3.
No.
This is 1 here. From this crest here to this crest. 1 complete wave. There I actually don't have a complete wave, it's 1.5. Clear? Now, if you look at this, the diagram shows, we talked about it here, what happens as it passes through this gap. Now, if you look at this gap here, it's almost equal to this. So that's why we've got maximum diffraction. That's what it is. Last time. Maximum cavity. Clear. Transverse longitudinal, which one is the answer?
B.
B. Correct. Now a boy throws a small stone into a point well spread out from where the stone hits the water and travels the other side. The boy notices 8 waves. What is the frequency? So use your calculation I told you. From the definition, you should be able to calculate here. What's the correct answer? For the waves? For the frequency, what's the frequency?
C.
Correct. Because it's number of complete
No.
waves. Number of complete waves. How many waves? 8 waves. In how many seconds does he notice that? 5. So you get 1.6. Number of
Yes.
complete waves per second. This was repeated. And this one here, did we do that? Transverse. Some of these questions. This was repeated. Again. And this one, what is the answer here? I think the rest of the questions are repeated here. So yeah. So please read the notes. I send you notes during on the website because we want to move on to the next topic. Please study your notes, and I even sent you, I think, a worked example question on waves. Read through your notes. You try to do the questions I sent you. Then we also want to move on to magnitudes. So we see you tomorrow.